Okay, we're going to go ahead and go through this practice test. Number one, it's in standard form of a circle, so we know it's opposite, opposite, square root. Should be 3 points. So 4, -8, and square root of 9 is 3. Write an equation with the center and radius. So now we're going backwards. So still opposite, opposite, but instead of square root, it's squared. So the opposite of 3 is -3. So x minus 3 quantity squared plus y plus 2 quantity squared. And the radius is 2. Remember, on the right side, it's r squared. So 2 squared is 4. All right, graph the following circle. Again, opposite, opposite, square root. So center is 2, -2 right there with a radius of 1. Go 1 in each direction. Draw yourself a circle. Complete the square. We get the x's and y's on one side where x squared and y squared are positive. So that's going to be on the left side. So we're moving all of this across, except for leaving the constant -2 on the right side. I line my x's up together. I put my plus blank. And remember, I can do half of b. There's b right there. Half of -14 is -7 squared is 49. Half of +8 right there is +4 squared is 16. So I'm adding 65 to the right side. So I added 65 to the left side. And then I can just drop those right on down into there. So I have x minus 7 quantity squared plus y plus 4 quantity squared equals 63. 65 minus 2 is 63. So then I go ahead and do the opposite for the center, and square root of 63 breaks down to 9 times 7, which is 3 root 7. You must simplify the answer. Now, you don't get credit for this problem unless you actually complete the square. You can't just write down what it is. It says complete the square. So I have to see that work. You've got plenty of videos you can go back if you need to watch on practicing completing the square. All right, write the rule to describe each transformation. So first thing I want to look for is the original and its image right there. If I connect those, it goes right through the center. So that's probably telling me it's a rotation of 180 going right through the center. Here's G and G prime going right through the center. So once it happens with two of them, it's guaranteed it's a rotation of 180. Rotation of 180, it always goes through the center, the image and pre-image points. I connect them, goes through the center. Okay. Now I could also check orientation if I wanted to. I go BXG and BXG. Notice both are the same orientation, counterclockwise, which means it has to be either translation or a rotation. Well, obviously it's not a translation. It doesn't look exactly the same. So it has to be a rotation. Okay. And then you can look at it, went 2 quadrants away. Here to here is 2 quadrants away. So it's a good chance it's 180 degrees, 90 plus 90. All right, here, this is a translation. I could check the orientation. It's the same orientation. And then I can look, okay, how to get from Z to Z prime. Went right 2, down 1. Right 2, down 1. Right 2, down 1. Okay, so I have to always write X comma Y maps onto, and then I went X, I went right 2, which is X plus 2, comma, and then Y down 1, Y minus 1. Remember, that is what a translation rule looks like. You have to write it like this if you want full credit. And if you forgot, here's an example of it right here. So there's no reason for you missing it on the quiz unless you don't pay attention. And on the test, I mean, all right, so here's an easy one. You just plot 2, -3, and you do what it says, right 2, down 1. Let's go right 2, down 1, and there's my A prime right there. So A is the original, A prime is the image. Okay, number 8. I graph those points and draw reflection over the line y equals 2. Y equals 2 is a horizontal line. Y equals any number is a horizontal line. You should already know that from pre-algebra, algebra 1, and again here and again in geometry. You've already done it. 3 years now you've been doing that. And so I draw that. Here's my pre-image right here, connecting that, and then I just reflect it over that line, the same amount. That's 5, so I go up 5. That's 3, so I go up 3. And A and A prime are right on that line itself, and then reconnect them. Okay, so reconnect it, and there is my image. Remember, it's got to be congruent. It's to be the same size and shape. It's reflected over that line. All right, write a translation rule that describes that translation. So a translation rule again is x comma y. You've already done it. You've already written it up on number 6, and you see it on 7. Done for you. How do I get from Z to W? I went right 2. I went down 6. So there's right 2 and down 6 right there. X comma y maps onto x plus 2y minus 6. Should be free points. Your ability to count. You know what a translation rule looks like. All right, rotation of 270 is the same thing as negative 90. So negative 90 goes, if I went from quadrant 1 to quadrant 4, so I reflect it over the y-axis, which switches the x-coordinates in negative x, comma y, and then over the line y equals x, which switches the y and the x, and makes it y negative x, therefore. Remember, I memorize off of the reflections over intersecting lines themselves. So now I just apply that, as I did right here, to a prime, b prime. So there's the a, b, and c, and just apply y negative x to each of those, and you get your a prime, b prime, c prime right there. Okay. Now I could have gone ahead and plotted the original if I wanted to as well. See, it's 1, 2, 4, 3, 1, 2, 3, 4, 3, and 1, negative 2. Okay, I'm rotating that 270 degrees or negative 9 degrees. So since these two are in quadrant 1, they're going to end up in quadrant 4, which is these two right here. That one's in quadrant 4, so I got to go over to quadrant 3, and there it is right there to reconnect them. Okay, so that makes sense. They rotated one quadrant clockwise. Okay. State where the figures in isometry. Remember, isometry is a ridge of motion. It means they're congruent. Are these congruent? No, this is obviously smaller, so the answer is no. 12. How many lines of symmetry does a regular pentagon have? Keywords regular. Lines of symmetry, it's always the same amount as the polygon itself. So pentagon has 5, so it has 5. So you have to know quadrilateral, triangle, hexagon, heptagon, octagon, nonagon, decagon, and dodecagon to be 12. You know your polygons from 8th grade math there. What's the smallest angle of rotation? I'll take the regular. It's always going to be a regular polygon. In this case, an octagon back onto itself. The smallest angle, that means they want 1. The smallest one, and it's always 360 divided by the number of sides, 8. 360 divided by 8 is 45 degrees. Now, if I wanted all the angles of rotation, I'd have 45, 90, 135, 180, 225, 270, 315, and I would not do 360. Okay, number 15, solve for x right here. Well, I know I have 2 sets of isosceles triangles here, and I have a right angle right here. So if that's 28, that's 62 to make it a right angle at 90 degrees, and then that's a base angle of the isosceles triangle. So that means this is 62 over here, because the base angles are congruent, which makes 124 from 180. I subtracted that right there, and I get 56 degrees for x. Okay, should be easy. 14. Remember, the first step in all proofs are write down the givens. So step 1, then I write down my free points. There's my free point. PT is congruent to PT. How do I know to write PT? PT, because it's right there for me. PT is congruent to PT. I didn't have to go PT to TP. Okay. Reflection property of congruence. Now I have enough information to say they're congruent by SAS, so I make this triangles congruent by SAS. And lastly, since it's asking me to show one of the corresponding angles are congruent, you know it's always going to be by CPCTC after proving the triangle is congruent. Okay, you'll have a similar one like that where you have 3 or 4 steps to do it. Should be easy, no long ones. All right, 16, we have an isosceles triangle again. This is 146 degrees, which makes this a linear pair. 34 degrees. So linear pairs means there's supplementary, which means they add to 180. Then I have an isosceles triangle, which puts this at 34 degrees. Then I have vertical angle theorem that puts that at 34 degrees. Then I have another isosceles triangle for the base angles that are congruent, so that puts that at 34 degrees. And then that forms a linear pair with that, which puts this at 146 degrees. Didn't ask for angle 2, it asked for x. So up here I see Angle 2 equals 13x plus 3, so that equals 146. Subtract the 3 across, I get 143. Divided by 13, I get x equals 11. Nice little pre-algebra there, 7th grade math. Okay, you've already done isosceles triangles all this year. You did it in 8th grade math as well. All right, mark the congruent sides and angles. So in a triangle, we got 3 sides and 3 angles. I better have 6 total pieces marked in each triangle. 3 sides congruent to 3 other sides, and 3 angles congruent to 3 other angles, and there you have them. You know, you go B to M, D to L, C to K. That's the corresponding order right there. And then you can do the same thing with the segments, just like that. Should be easy. All right, 418 and 19 say how you know the triangle's congruent. Well, I can get my free point right there, and then I have SAS. Okay, here I can get my free pointer reflection property, and now I have SSS. Very simple. Okay, nobody should be missing that. And lastly, what do I have to? Well, I get my free pointer reflection property, and I need it to be ASA. So what piece do I have to ask for? Well, there's an A, there's an S, so here's my other A I need. I need that angle congruent to that angle. And we name it with 3 letters. There's more than one angle there. So QCD is congruent to ECD. Remember, we put it in corresponding order because Q matches up with E. C matches up with itself, and D matches up with itself. So write it in corresponding order. All right, that does it for your test. Just like that, there's different numbers or drawings tomorrow.